All right, well, our presenters are all here, so I'll welcome everyone to today's webinar titled Live AWS Privilege Escalation Attacks and the Controls That Actually Stop Them. My name is Karen Levy. I'm with Sonrai Security, and I'll be your host today. And if you don't know Sonrai, we are laser focused on understanding permissions in all three clouds, and particularly focused on privileged permissions, those that can be used to execute an attack. And we have a solution that secures all of them and brings your identities to least privilege and cleans up all the mess of overprivileged identities, unused identities, all that stuff in your cloud. But today we're going to talk about how those privileged permissions can actually be used in a real attack. And we're going to see a live demo, which is always great to see on a webinar. I just have some quick housekeeping. If you have any questions, please feel free to throw it in the chat. We're going to have time at the end to ask those questions to our presenters. Don't be shy, share your opinions, ask your questions. We really love the interaction with the audience. And before anyone gets a chance to ask, we will be sharing the recording of this after the session. So no need to take screenshots, but you're welcome to do so if you want. All right, with that, I'm excited to introduce our presenters. Today we have Julian joining us from the great pen testing company called Software Secured, and Nigel, who is a colleague of mine here at Sonrai Security. So with that, I'm going to head backstage for the bulk of the presentation, let them introduce themselves and take it from here, and I'll be back for Q&A. Take it away, Nigel and Julian. Thanks everyone again for joining.
Yeah, so as Karen mentioned, I'm Nigel Sood. I work for Sonrai Security, and my job is to do identity and access management research for the three major cloud providers, AWS, GCP, and Azure. And one of the things that I do day to day is just dig into identity and access management permissions, all the new stuff that AWS is publishing in terms of services and features, and try and figure out what hidden privilege lies within there.
And yeah, thank you very much, Karen, for the introduction. I'm Julian. I'm with Software Secured. I'm a penetration tester there, and I've been there for coming up on 2 years now. My primary focus is web application exploitation, looking at cloud security, looking at mobile applications, and hardware security as well. So I hope you guys enjoy today's presentation.
All right, so I will pull everything up. Hopefully you can see all this. So to give a quick background and kind of what this webinar is about and how Sonrai Security and Software Secured got on this topic to begin with, we really wanted to get like a distinct hands-on feel for the types and classes of privilege escalation that's now available in AWS. As new services have released, as new services and features within existing services have come out, the types and complexity of privilege escalation in AWS has gone up and up over the years. So we wanted to get a really hands-on feel for this. And we also wanted to see what sort of control mechanisms that are cloud native, that leverage cloud native tools exist to help prevent these different types and classes of privilege escalation techniques. So in our original stab at this, we had tested 16 different things in both controlled and uncontrolled environments, and to see which of those 16 privilege escalation techniques were still viable and which of them would be viable in a controlled environment. So we have a little bit of background information on some of this. Some of them we'll jump right into the live demos. But Julian, if you want to take us away.
Yeah, thank you very much, Nigel. Like you had said, Nigel, late last year, Software Secured paired up with Sonrai to look at 16 different privilege escalation paths. And as part of this research, we tested each one in a normal AWS environment, looking at things like Lambda, SSM, Elastic Beanstalk, CloudFormation, and most topical and interesting for today, Bedrock and Agent Core, all as different paths to escalating privileges. There wasn't anything unusual about the configurations. There wasn't any strange requests that we were making. It was all sort of things that you would see in real AWS environments. And in each case, in just a standard AWS environment that was not protected, we were able to escalate privileges to an administrative level and essentially take over the full account. Once Sonrai's Cloud Permission Firewall was implemented and protected the environment, each one of these pathways was stopped, and we were prevented from gaining the privileges that we really were going for in that research. And so it was a real demonstration of what it can do and what it can do to prevent bad guys like me from escalating privileges within an AWS environment. So that's a little bit on the research, and I'll turn it back over to you, Nigel, to continue on the background.
Sure. So looking at privilege escalation in AWS, one of the things that Julian, you mentioned that I really want to harp on here is that this was using permissions in the way that they were intended to be used. It's using the AWS control plane the way that it's intended to be used, using those service endpoints to perform actions that are still going to be performed every day in your cloud by human and non-human identities to do the things that they need to do in AWS for whatever you're using AWS for. It's not leveraging vulnerabilities. It's using the cloud the way the cloud's intended to be used for kind of self-gain to gain access to more privilege. And there's a lot of different ways that this can occur. In the most simple case, you're using identity and access management permissions directly. And I'm talking specifically about permissions in the identity and access management AWS service. This is doing things like literally adding privilege to identities by attaching or editing policies, assuming roles, manipulating group assignments, like all that sort of stuff. A step up from that in terms of complexity, you're looking at individual services. And the title of the slide here, if a service can act for you, it can escalate for you. And that's truly the case in AWS nowadays. Originally, privilege escalation was all about those identity and access management permissions. Now it's also service-based. Many services use non-human, what we call execution roles, to perform AWS control plane actions themselves. A classic example might be an EC2 instance that needs access to an S3 bucket or needs access to published CloudWatch logs. You're going to give it an identity and access management role that has permissions so that it can do the things that it needs to do on its own. The problem is that when you have a configured compute environment with identity and access management credentials, those credentials either live on or are accessible by that compute environment. So anybody who can, run arbitrary code or arbitrary commands on that compute can pull those credentials out, and that leaves a path. You create a privileged compute, you gain access to run arbitrary code in that compute, you exfiltrate the credentials, and then you can leverage those new credentials. We're also now looking at kind of an extension of this, where not only do we have these privileged compute environments, but we also have new ways that we can invoke them. One of the big new things that AWS has been pushing recently is Amazon Bedrock and all the different little things that are associated to Amazon Bedrock, leveraging LLMs to speed up development, speed up development operations, while integrating AI very, very tightly with the AWS control plane itself, giving it access to monitor things and also do things like invoke Lambda functions. So we've got kind of these three eras of privilege escalation. You might call them. You've got era one, which is this really basic, identity and access management based privilege escalation by doing identity and access management things. You've got the service-based privilege escalation where you're leveraging roles that you're passing to services to go and eventually take on those credentials. And then you've got kind of this new era that we're in right now, where you have these really complex kind of orchestrated mechanisms of invoking those service, those past service roles through things like LLMs. And there's a whole bunch of classic examples of all the service-based stuff: Lambda, SSM, Elastic Beanstalk, all the things you can see on the slides. And we'll be looking at some of those today. So when looking at new identity and access management privileges in AWS, which is something that I do every morning when I come into work, if you want to figure out which ones you need to be worried about from the lens of privilege escalation, there's a bunch of different questions that you can ask yourself. And this kind of tackles all three of those categories that we just mentioned, but the general questions are: does it allow code execution? If so, and it allows code execution in an environment where there's an execution role, there's a high likelihood that you can use that to access IAM credentials. Can it create or modify credentials directly? Can it modify permissions? Does it allow cross-service privilege routing? That one's important because if you can talk to a compute within a different service that has identity and access management credentials, that's often a way to kind of pivot into an environment where you can gain access to new privilege. And 5, which is pretty similar, can the permission move attackers laterally into compute services. So, you see that entire kind of hierarchy of stuff. You've got the direct permission management type things, but also the access to compute environments to privileged compute environments. And so we talked about, running these tests, running these 16 privilege escalation techniques in, both a secured and an unsecured environment. Uncontrolled is easy. You just run the examples as per normal. You spin up a new AWS environment, you go set up your scenarios, and then you go and run them. No mechanisms in place to prevent those specific scenarios. For controlled, as Karen and Julian mentioned, we use Sonrai's Cloud Permissions Firewall. So some more details on that, on the product later. But specifically, the things that we were looking for in terms of, what constitutes a controlled environment are something that can identify unused privileged permissions and identities, and then specifically put controls in place to block access to that unused privilege. So we're talking about kind of enforced least privilege here. So it's specifically unused privilege permissions, unused regions, unused services. All of that can be locked down. Under the hood, this is implemented in part using a combination of attribute-based access control and complex SCPs and RCPs, service control policies and resource control policies in AWS organizations. And then, a feedback mechanism, less important for the actual testing of the privilege escalation scenarios. But if you were to actually implement something like this, you would want a system in place such that when access is needed, it can be granted on demand. And we'll talk a little bit more about the Cloud Permissions Firewall later. But just when thinking about the demos that we're about to do, this is what a secure environment is. You've got actual controls in place, blocking specific privileged actions with alerting and access being granted back as needed. And on to the demos. I'll pass it over to you, Julian.
Thanks very much, Nigel, and great background there. So with each one of these scenarios, I'll give you a little bit of background before we go into it, and then I'll walk through what's going on. So in this case, IAM privilege escalation by rollback. We'll be starting with a highly limited IAM user who's been compromised. The attacker, in this scenario, it's me, is able to review previous IAM policy versions and restore one which allows full administrator privileges, resulting in a privilege escalation. So let's go ahead and get started. Okay. And there we go. Great. Everything can be seen here. Good. So the first step after gaining access to an IAM user, an attacker would take, is to go through and enumerate those privileges that have been assigned to it. In this case, we're looking at first the inline policies, which are policies that are applied directly to just an individual user or group or some sort of resource within IAM. And in this case, we see that there is nothing there. Now, when we look at the managed policies, we see is this Raynor policy that has been assigned to this user. And managed policies are those which are managed either by AWS or an AWS customer and are applied more broadly to users or groups or other resources within AWS. Now, in IAM, or Identity and Access Management, each policy can have multiple versions up to a total of 5, but only one version at any given point is set as the default or active version. Whenever you edit a policy, IAM is going to create a new version, leaving older versions saved in the background, and those older versions may have privileges that aren't readily apparent in the default version. And if an attacker can switch to the default version to a more permissive policy, they could perhaps elevate their access. So let's take a look here and see what policy versions are available for this policy. And we see there are 5. We are currently on version 1, but there's version 2, 3, 4, and 5 all available. And now what we can do is inspect the actual details of those policies and see what is there. So this version 1 that we have access to allows us the ability to get, list IAM resources, as well as set the default policy version. Now, if we iterate back another version and run this, we see not as interesting permissions, but when we go back to version 3, we have the ability to perform any action on any resource within AWS. And that's a lot more interesting. It's effectively administrator access. And so we can now run set default policy version on that and change the version to version 3 for the default. Wait a minute there. And now when we run list policy versions, what we'll see is that the default policy version has changed from V1 up to V3, and we now effectively have administrative access over all resources in AWS. A fairly simple attack scenario, very easy to exploit, and quite common as well. So let's get ready for the next scenario. Let's go here.
That's like one of the classic AWS privilege escalation tactics.
Yeah. Okay, so the next scenario, Lambda privilege escalation. So after having compromised the IAM user Chris, the attacker, still me in this scenario, enumerates the environment and determines that they can assume a role that has full Lambda access as well as PassRole permissions. And so the attacker can exploit this to escalate their privileges up to administrator. So let's go ahead and switch back to the screen with the terminal. Yeah. Great. So again, going back to sort of those first few steps, enumerating the privileges that are assigned to our user, we'll take a look at the inline policies first. Nothing there. And let's take a look at the managed policies now. And we see there is this one policy, the Chris policy, that's assigned to our user. Okay, and now we want to see what exactly is going on with this. And to make things a little bit shorter, there's only one version of this policy. And here we can see that it has the ability to list and get IAM resources, which makes sense since that's kind of what we've been doing, as well as the ability to assume role with STS. So a very powerful policy or permission that's been assigned to this policy. So since we have the ability to list IAM resources and assume roles, we should actually see what roles are in the account. So I'll list those out and just filter for what's relevant for this case. And what we'll see here is the Lambda manager role. And this can be assumed by Chris. So we can gain access to sort of Lambda functionality through that, as well as the debug role here, which can be assumed by Lambda. So it seems like there's a pathway over to this debug role. So a little bit of background. To assume a role in AWS means to temporarily take on the access permissions associated with that role. It's a way for an AWS user or service to grant or to gain credentials that allow different or perhaps greater privileges without permanently attaching those permissions to the primary user or identity. It's a little bit of a more secure way of going about it. So let's take a look at the attached role policies for that Lambda policy. And we see this ARN here for this Lambda role, sorry. And let's get information about that. Oh, let's see. Sorry about that. No, seem to have messed up on that. Bear with me here. This right now, no. Okay. Second. Leave it to AWS to make things as complicated as possible some days. No? No, that's it. Sorry, some earlier testing. There we go. Apologies, ladies and gentlemen. It's what happens when you do live demonstrations. So here we can see that the Lambda policy allows effectively any Lambda action and IAM pass role. So we can create, modify, delete, or invoke Lambda functions. And it also allows us to pass role. So we can potentially escalate privileges by attaching a role with higher permissions to a Lambda function. Now let's take a look here at the attach role policies for the debug role. And the debug role has effectively administrator access. So we don't even have to really run anything additional, because if we can get this, we can, if we can compromise this role, we can compromise the full account essentially. So I'm just going to run this quick command here, which will generate temporary credentials for the Lambda manager profile and allow us to assume that role. And we'll confirm that we've successfully assumed that role by calling getCallerIdentity with that profile. And so we can see that was indeed successful. We've now assumed the Lambda manager role. So our next step is to go through and create a Lambda function for privilege escalation. I've already gotten the code set up here, but essentially what it will be doing is attaching this administrator access policy to the user Chris when the Lambda function is executed. Now that we have that all set up and prepared, let me just make sure the user ID is correct. Yes, indeed it is. We'll zip up that Lambda function, and now we can run Lambda create function, and this will take that code that we have zipped up, upload it, and create a new Lambda function within AWS. Let's hope this all works out well. Seems like it has so far. And now we shall be able to execute this new Lambda function. And when that is invoked, it should provide our user Chris with the administrator privileges. So we'll wait here a second. And the status code 200, indicating that we were successful. And we can confirm that the user policy has been attached to our user by running list attached user policies on the profile Chris. And we can see that we successfully attached the administrator access to our account, and we have now compromised the AWS tenant, and we can really do whatever we please. Okay, and that ends that one there. And now for the final one, which is the Bedrock. So I will give a shout out to Nigel for having designed this this scenario. He did a great job with it. And in this case, what we'll be doing is starting out with an IAM user named Grace. So we've compromised Grace, and the attacker discovers, again, still me in this scenario, that they have limited Lambda permissions and can invoke a Bedrock agent. By interacting with that agent, we determine that the agent is leveraging a Lambda function to conduct a real-time inventory of cloud resources. The attacker then uses their limited Lambda permissions to change the function behavior and has the agent retrieve the flag from S3. Okay. And let's get this chat again. So once again, we'll start out by checking those managed policies and seeing what is available to us. In this case, we have three. We have the IAM read-only access, we have agent access policy, and Lambda deployment policy. We'll only really look at these two here because the IAM read-only policy is pretty self-explanatory. So let's take a look first at this here. Let's re-exploit this. Let's try this again. There we go. And here we have effectively most of the things that we can do on Lambda, but importantly, we have the ability to update function code and update function configuration. So quite interesting permissions to have been assigned to us. And let's take a look at this here. Let's see if I exported this. I did. And here we have the ability for the Bedrock policy to get and list Bedrock agents, as well as invoke agents. So we can't make any modifications to these agents, but we can get them, we can list them, we can invoke them. So still fairly interesting. But since we can't list any functions within the environment with that Lambda permission, we should probably take a look at what Bedrock agents are available to us and figure out from there and enumerate that information. So let's go ahead and list the agents. In this case, we only have one agent ID. So let's exploit this just in case I'd forgotten earlier. And it's this Bedrock agent here. So what we can do now is actually chat with this agent. We can't interact with it over the Bedrock user interface, but we can use the Boto3 SDK to talk to our agent. And I believe that is correct, yes. So we can open up a Python interactive shell, and here, just by running converse, we'll chat with our AWS agent. So we can see what can it do. It can perform various things, including listing or inventorying IAM roles, users, EC2 instances, and S3 buckets. And let's see what S3 buckets are in there. So there's this bucket with the name CG Bedrock secret flag. Very interesting, perhaps what we should be looking for. So let's close out of this. Now let's take a look at the agent action groups for this agent and see what is there. The agent action groups will have some more details about what it actually has access to. And if I've done this correctly, yeah, we can see here the Lambda function that is associated with this agent action group. We can see the description, which is essentially saying that it exposes a Lambda function that inventories cloud resources, as well as the different capabilities that that has. Now that we have the function ARN, we can put our Lambda permissions to use. And we can call this here to find out some additional details, including the role and that it's executing with. We could try to execute this Lambda function directly, but because we don't have the ability to invoke, we're going to be denied and can't do anything there. However, what we can do is replace the function that is used by that Bedrock agent action group. So what we can do here is similarly to what we had done in the previous demonstration, we can put together a little script which will list objects within the S3 bucket that we're looking at. Once that's been done, we can take that and we can update the function code. And failed. Okay, let's get this changed here. Okay. Update the function code, that succeeds. And now to interact with that updated code, we can start a chat with AWS. So converse what resources are in AWS. Let's see if it's taken enough time. Great. Now, we shouldn't have been able to see what files were in the S3 bucket beforehand, but now we can. So we can see that there's this flag.txt file. Now, in order to be able to actually read out the contents of that flag, we'll have to update that Lambda function code again. And this time, adding additional permissions to that, the S3 get client object ability for that bucket and that flag. That's what we'll do here. And we'll go back and update the function code once again. And now that that's been done, give it a second, allow the code to finish updating, and we'll start a chat. And again, conversing with that AWS agent, we'll run this here and see what comes back. Fingers crossed. Yes. So now the AWS agent has gone and actually read the file flag.txt that's within that S3 bucket and has returned its contents to us, allowing us to get access to things that we really shouldn't have been able to with the permissions that we had assigned to our user. And now with that, I will hand things back over to Nigel.
Yeah. Great. That's those were some amazing demos. Definitely showing the kind of increase in complexity as time goes on. Especially with the last one, having to go and examine that entire kind of chain of infrastructure being leveraged by AI in the cloud, and then kind of picking away at the underlying infrastructure in order to actually get there. Julian, did you want to pull the slides back up, or do you want me to do that?
Yes. Yes. Let's get that.
And actually, just to answer one of the questions that I can see in the Q&A right now, what privileges are required to execute these commands? The attacker should already have these privileges to change the version. So that's probably talking back to the privilege escalation by rollback. And yeah, you're exactly right. The whole point of these privilege escalation techniques is to go from a relatively low privileged identity to a relatively high privileged identity. We're not talking about compromising identities here. The cases that we're demonstrating, we're going to assume that's already happened. Be it credentials that got leaked via GitHub, be it an insider threat, be it somebody got hit by a phishing attack. Somehow, again, relatively low-level identity that has specific permissions is able to pivot to an identity with higher permissions. So in the first example that Julian did, we went from an identity that only had the specific IAM set default policy version permission, and they went from just having that one permission to having full administrator access just by nature of how the IAM system was set up in that AWS account. And the second one, they went from having a couple of identity and access management permissions, namely PassRole, and having access to create Lambda functions, to leveraging that Lambda function to give themselves administrator access. We're going from having some permissions, definitely having a few high privilege permissions, to having all permissions or administrator access, or access, in the last case, to an S3 bucket that you couldn't access before. There is definitely a permission requirement to begin with, but you're using those permissions to gain access to more. And that kind of goes back to what we were talking about with privilege permissions before, and how you can identify privilege permissions as those permissions where, if on their own, an identity having access to them can gain access to more. So what can we do about these privilege escalation techniques? We'll talk a little bit about the Cloud Permissions Firewall, the controlled environment that we used for this testing. But there are some things that you can do, if you don't have Sonrai's product. We're not here just to talk about the Cloud Permissions Firewall. You can also use cloud native tools. For example, one of the really easy things that you can do is use SCPs. Now, you need to use these with extreme caution, because again, we're talking about permissions that are genuinely needed, in AWS accounts for legitimate purposes, and you don't want to be blanket blocking access to permissions that any of your human and non-human identities might need, but there are some that you can. If you don't have a lot of people doing identity and access management in an AWS account, maybe you can get away with restricting access to set default policy version. If you're using Lambda, it might be a little bit harder to get away with restricting Lambda create function, but oftentimes for kind of the more niche privilege permissions, you can use SCPs to just blanket deny access to them across your entire AWS organization. You can also use it for other things like blocking unused regions or services, so that if you have an AWS account that's, say, dedicated entirely to AI, or you have one that's dedicated entirely to hosting your web servers, you can block down any of the services that you're not using. Say you're not using Lambda, you can restrict access to that across an entire AWS account, so that even if somebody who has administrator access or Lambda access who shouldn't have it can't do that Lambda example that Julian has showed, where by creating a function they can attach IAM policies back on themselves. So that's one option, SCPs, using centralized controls through AWS organizations. Another thing you can do is just general good least privilege hygiene. Review the trust policies for any of your privilege roles. So, kind of go through, inventory what some of those high profile privilege permissions might be, see who has access to them, and then see what the trust policies on those roles are, to make sure that only the people who have access to those roles need them. And you can also use things like Access Analyzer to review who has, access to specific privileged permissions, and then lock down that access if it's not needed. One of the nice things that you can do is go and find unused access in this way. And then, we'll talk a little bit more about the Cloud Permissions Firewall. You can use that to effectively do those first two things in an easier to use and more automated fashion, putting in those controls that we put in place before, looking for unused access, restricting privileged access that isn't needed, and then having a system in place to be able to grant it back if needed, kind of mitigating some of the danger of using those SCPs, whereby, you want controls in place, but you don't want to break anything. All right. And I'll pass it back to Julian to take a look at what this might actually look like in a Cloud Permissions Firewall environment. So, we talked about doing these demos in the uncontrolled environment, and you saw them all work as Julian was doing it in his terminal. Now we'll look at, what might happen if you tried it in an environment where something like Cloud Permissions Firewall or, SCP-enabled controls, where they were implemented.
Thank you, Nigel. Yeah, that was really a great explanation. And I would love to add to, like, some of the research that you guys did as part of your last webinar. I believe you had said that some of the escalation paths that I just demonstrated were things that you had seen in your own research there in the wild.
Yeah. So, recently we've seen a number of crypto mining campaigns occurring in AWS, and one of them that occurred, I can't remember if it was late December or early January, but they were actually using privileged Lambda functions, so creating Lambda functions with execution roles, the same way that you had just done in your demo, to go and create persistent access. They created a Lambda function that had identity and access management privileges, configured the Lambda function to use those privileges, just using those two permissions, the Lambda create function and IAM PassRole.
Yeah. Okay, so yeah, let's go back to what we were doing here and go back to the terminal, but this time in a protected environment, as was described. So the key thing in that first demonstration was actually changing the default policy version. And so let's try that again, but this time in a protected environment. So I'll run this command here, and what we'll see is that it will simply fail. We'll get to that in just a second. Same thing over here. Let's try to create that Lambda function within the environment with the Lambda privilege escalation path. And that should fail as well. It seems like I may have gotten something wrong though. One second. I'll have to get the debug roll back out of here. Sure. And okay, security token is expired in this case. It would be blocked in this scenario, but security token expired since I had gotten it set up. Let's see if we can run this one here. Demo. So not authorized to perform, and we'll see here on this, we should see some requests come in with the permissions on demand, trying to get those privileges provisioned for the requests that I was just running. And is it sharing my screen properly? No.
Yeah, so one of the things that we mentioned about the Cloud Permissions Firewall is that it puts the restrictions in place, and I had mentioned that under the hood it works a little bit with service control policies and resource control policies. You might have seen in those error messages, Julian, that in some cases it'll say, you were not able to perform it because of an explicit deny in a service control policy. That would be the service control policy that the Cloud Permissions Firewall put in place when you configured your controls. Mm-hmm. And talking about getting that access back whenever you need it, whenever you attempt to perform with an identity that's been protected, whenever you attempt to perform an action that you are no longer able to do because of the controls implemented by the Cloud Permissions Firewall, you'll get an alert in the product, which has a kind of dual use there. You can see when people are trying to perform, unauthorized actions. So it acts a little bit as an audit mechanism, but also as a mechanism to grant that access back. So, in this case, if you were trying to do something as a bad actor, somebody's going to latch onto that and see, hey, that identity shouldn't be performing that thing. We should deny this and, maybe do some investigation here. But if this is as, somebody from your DevOps team who's trying to do some work that's, truly necessary, you can approve that either indefinitely or even just for a short period of time, kind of removing standing permissions, but granting back access to those privilege permissions, just as needed.
Exactly. Great. And then I shall switch back to the presentation here. Go.
All
right.
right. Presentation, great live demo. Love to see it. I learned a lot, and we got some great feedback in the chat and a couple questions. So really quick, resources here. There is a QR code for the full software secured testing report, so you can see their full methodology and the results of all 16 tests. And if you want to try out the Cloud Permissions Firewall and see what that controlled environment looks like, we have a free trial. So just put your email address in on our website, click that QR code, put your email address in, and you can get full access to the Cloud Permissions Firewall for 14 days, no questions asked. But Julian and Nigel, I think folks are interested in learning more about where they can access these attack paths. What is the URL for this? Capture the flag. Where do these come from? Are they really standard?
Yes, so there were three that we leveraged kind of across this entire exercise, and these are all things that are open source that you can go and play with right now. The first is I Am Vulnerable. That's something managed by Bishop Fox. I am as in IAM, vulnerable. If you Google that, you'll go find the GitHub repository. That's got a collection of a whole bunch of identity and access management based privilege escalation. So like, your IAM set policy version or set default policy version, IAM create access key, all the like core IAM permissions that enable privilege escalation and persistence. There's a whole bunch of stuff in there for testing your skills with those. There's also, for the more kind of service-based things, CloudGoat is one of the ones that we were using for this demo today. And CloudFoxable, I believe, is the third. CloudFoxable managed by Bishop Fox and CloudGoat managed by Rhino Security Labs. These are all open source. You can go play with them yourself, set them up in your own environments, and try your hand at performing some of these privilege escalation techniques.
Yeah, no, I couldn't have said it better myself, Nigel. And if you're as eager and excited to try out new configurations and things like that as well, you can set up your own templates with Terraform to be able to configure your AWS environment however you like. Like I said, the Bedrock scenario was actually one that Nigel created. I believe you've got a pull request on the CloudGoat repo to get that merged. Yeah. So yeah, it's cool stuff there.
And there's some other, if you look at the pull requests for CloudGoat, you'll see some other AI-based privilege escalation techniques specifically that are there. As AWS releases new services, there's going to be plenty more of these examples. Anything to do with IAM PassRole, there's potential for some shenanigans in there. So new stuff is getting added to those all the time. So if you want to stay up to date on them, you'll find some interesting things.
All right, we have another question here. We're running up on time, but people are still hanging on for Q&A. So let's keep going if you don't mind, Nigel and Julian. Question, it seems that badly managed IAM roles enables these attacks. I don't know, I'll add my 2 cents before I toss it over. We look at cloud environments all the time, and there are a lot of badly managed IAM roles in cloud environments that people don't realize or know about. We have the cloud permissions firewall, the first thing it does is identifies all the excessive unused permissions. We've done research that says 92% of roles with privileged permissions don't ever use them. And so while it may be true that poorly managed IAM roles enable these attacks, they're probably more common than you think. But that's just my 2 cents as the moderator. Nigel, Julian, what would you add?
I'll let Nigel touch on that first.
Sure. So I would say that in a lot of these examples, that's definitely a really good observation in that there's, it's narrowed down to a really small subset of permissions where if you were to look at them as an IAM policy that were in production, you would go, why is this group of permissions here and why is this configured this way? I think the reason that you'll see that in a lot of cases like this is because this was designed as a CTF challenge and to demonstrate kind of the minimal permissions that you can perform this style of attack with. So these roles are scoped just big enough that you can perform a privilege escalation technique using this path and still show it to be viable. Like Karen said, in a lot of cases, you've got roles that are much, much wider scoped that have access to these permissions and probably enough to perform even other privilege escalation techniques as well. But you'll see star permissions all over the place. Somebody with IAM star, somebody with Lambda star, and then IAM PassRole. And those are, effectively the same roles in that they grant the same permissions and even more. And those you see all over the place because nobody really wants to scope their roles down to exactly the permissions that are needed. You want to kind of get the, quote unquote, smallest role definition possible that allows you to do the things you need to do. But in this case, that just means giving star permissions because, it's the easiest thing that you can put in that gives you the permissions you need. So in a real environment, you'll probably see more permissions in these roles granted via wildcards that still have those kind of same toxic combinations of permissions that will enable these privilege escalation techniques.
Yeah, absolutely. And of course, there's also the consideration of, as organizations grow and have spent years within AWS, they'll have, these zombie identities, which I know the Cloud Permission Firewall does a great job of finding, of people that have left the organization that never had their accounts disabled and things like that may have been assigned permissions that were forgotten about or haven't been audited in quite some time. And so it's very easy for an attacker to get access to a role with what they need in order to escalate privileges when there are no additional protections in place.
I'm sure as a pen tester, those are always juicy finds.
All right, Vinay has popped in with another last question. I'm not sure if you can see this one, but so is star is the target or wildcards?
Yeah, star would be star is like a wild card. So in AWS, if you were to grant somebody IAM star permissions like IAM colon star, what that effectively does in an identity and access management policy with an allow effect, if you grant somebody IAM star, it effectively grants them all, permission to perform all actions within the identity and access management namespace. Similarly, like for Lambda, if you grant somebody Lambda colon star in an identity and access management policy, it grants them all Lambda permissions. It's a really easy way of making sure if you're a Lambda developer that you have all the permissions that you need, but it's probably going to be even more permissions than you actually need.
Yeah.
And often include permissions that leverage or enable privilege escalation tactics like the ones you've seen today. Sorry, Karen, I interrupted you.
No, I think we're going to wrap now. We've answered all the questions that have come in. Seems like folks are thanking us and going to pop off to their next meeting. I want to thank everyone for joining and for participating. Great interaction, great questions, which is what we love. And Julian, thank you very much for presenting from Software Secure. That was great. Great to have you on our webinar. And Nigel, great to have you as always. And we'll be sending a recording and look forward to continuing the conversation on the next webinar. Thanks, everyone.
Thanks.
See you, folks.